Does a mirror produce an image?
The light reflected from an object by a flat, or plane, mirror is not redirected, so it will converge again. What you see when you look in a mirror is a virtual image. It is located behind the mirror. Some of the rays from the object are reflected by the mirror and enter your eye. Your eye believes that all these rays came from a single point, and that point is behind the mirror. The image isn't real, it is virtual. Virtual images can also be formed by lenses. They cannot be focused on a screen.
What do AM and FM mean?
Traditional radio broadcasting uses analog, not digital, methods. AM, or amplitude modulation, and FM, or frequency modulation, are methods of transmitting information on a radio. In each case, a property of the carrier wave is changed, or modulated. These variations carry the transmitted information. AM was the first method invented and the simplest to transmit and receive. Edwin Howard Armstrong demonstrated transmission and reception of frequency modulation in 1935. Listeners were amazed the way that FM eliminated static because noise, like that due to thunderstorms, changes the amplitude, but not the frequency of signals. The FM receiver's output does not depend on the amplitude of the signal. Due to opposition from the radio networks and receiver manufacturers, commercial FM broadcasts were delayed and did not become widely available until after World War II. Radios once only had AM, amplitude modulated, frequencies available. Then came FM, frequency modulated, in 1939. Today, there is talk among radio professionals that AM stations might become a thing of the past.
What is a thermograph?
Picture that shows the temperature of every location in the picture. Thermometer device to measure temperature.
What is the timbre?
Quality of sound. Sound spectrum produced by an instrument, characterized by relative amplitudes or harmonics.
What are the subfields of physics?
The word physics comes from the Greek physis, meaning nature. Aristotle, 384 to 322 BCE, wrote the first known book entitled Physics, which consisted of a set of 8 books that was a detailed study of motion and its causes. The ancient Greek title of the book is best translated as Natural Philosophy, or writings about nature. For that reason, those who studied the workings of nature were called natural philosophers. They were educated in philosophy and called themselves philosophers. One of the early modern textbooks that used physics in its title was published in 1732. It was not until the 1800s that those who studied physics were called physicists. In the 19th, 20th, and 21st centuries, physics has proven to be a very large and important field of study. Due to the huge breadth of physics, physicists today must concentrate their work in one or two of the subfields of physics. The most important of these fields are listed below. The Greek philosopher Aristotle wrote the first known book about physics. Quantum mechanics and relativity, both of these fields study the descriptions and explanations of the way small particles interact, quantum physics, the motion of objects moving near the speed of light, special relativity, and the causes and effects of gravity, general relativity. Elementary particles and fields, the study of the particles that are the basis of all matter. Both their properties and their interactions are included. Nuclear physics, the study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed. Atomic and molecular physics, the study of single atoms and molecules that are made up of these atoms. Studies include interactions with each other and with light. Condensed matter physics, otherwise known as solid-state physics. Condensed matter is a study of the physical and electrical properties of solid materials. An exciting new study is that of nanomaterials, leading to nanotechnology. Electromagnetism and optics studies how electric and magnetic forces interact with matter. Light is a type of electromagnetic wave and so is a part of electromagnetism. Thermodynamics and statistical mechanics studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects, statistical mechanics concerns the atomic and molecular motions of very large numbers of particles, including how they are affected by heat transfer. Mechanics deals with the effect of forces on the motion and energy of physical objects. Modern mechanics studies mostly involve fluids, fluid dynamics, and granular particles, like sand, as well as the motions of stars and galaxies. Plasma physics. Plasmas are composed of electrically charged atoms. Plasmas studied include those in fluorescent lamps, in large screen televisions, in Earth's atmosphere, and in stars and material between stars. Plasma physicists are also working to create controlled nuclear fusion reactors to produce electricity. Physics education research investigates how people learn physics and how best to teach them. Applications of physics. Acoustics. Musical acoustics studies the ways musical instruments produce sounds. Applied acoustics includes the study of how concert halls can best be designed. Ultrasound acoustics uses sound to image the interior of metals, fluids, and the human body. Astrophysics studies how astronomical bodies, such as planets, stars, and galaxies, interact with one another. A subfield is cosmology, which investigates the formation of the universe, galaxies, and stars. Atmospheric physics studies the atmosphere of Earth and other planets. Today most activity involves the causes and effects of global warming and climate change. Biophysics studies the physical interactions of biological molecules and the use of physics in biology. Chemical physics investigates the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions. Geophysics is the physics of Earth. It deals with the forces and energy found within Earth itself. Geophysicists study tectonic plates, earthquakes, volcanic activity, and oceanography. Medical physics investigates how physical processes can be used to produce images of the inside of humans, as well as the use of radiation and high-energy particles in treating diseases such as cancer.
Does the speed of light depend on the medium?
Waves travel at different speeds when traveling in different materials. In the vacuum of space, light travels at 299,792 kilometers per second. When light encounters a denser medium, however, like Earth's atmosphere, it slows down ever so slightly to 298,895 kilometers per second. Upon striking water it slows down rather dramatically to 225,408 kilometers per second, 3/4 of its original speed. Finally, when light passes through the dense medium of glass, it slows to only 194,670 kilometers per second. The ratio of the speed of light in a vacuum to that in a medium is called the refractive index, represented by the symbol n. The refractive index will be discussed in further detail in the section on lenses.
What are streamlines?
Lines that represent the flow of a fluid around an object or through another fluid.
What does it mean to say that water seeks its own level?
The surface of water placed in a single container, a glass or a bathtub or a lake, will remain at the same level relative to Earth on both sides of the container. Adding water to one side will only make the entire level uniformly rise. There can never be one section of the glass or tub or lake that is at a higher elevation than another section. To understand this fact, consider adding the small cube of water on top of the surface at one location. It would exert a downward force on the water under it. But, because water can flow, water under it would flow outward, raising the level elsewhere in the container until the pressure is equal everywhere. Water also seeks its own level in other containers. If you fill a hose or tube with water and hold the tube in a U shape, The water level will be at the same locations in the two ends. You can use the U-tube to make a device to show you equal heights at two different locations. You may have a coffee maker that has a water height indicator on the side. This is a small tube that connects to the water reservoir at the bottom. The water level in the narrow tube and the wide reservoir is the same.
What is psychoacoustics?
Psychoacoustics, which connects acoustics with psychology, is the study of how the mind reacts to different sounds. This field of study is especially important to consumer product manufacturing, because a consumer associates particular sounds with certain products or sensations. For example, people associate low-frequency rumbling sounds with power and torque, while higher frequency sounds often represent high speeds and out-of-control occurrences. Psychoacoustics can play a major role in the development and commercial success of many products.
What nuclear force is responsible for beta decay?
The weak nuclear force is the cause of beta decay. It is 10 to 13, 1/10 trillionth, as strong as the strong force. As a result, the half-life of most beta-decaying nuclei is long. In 1968, Abdus-Salam, Sheldon Glashow, and Steven Weinberg showed that the electromagnetic force and the weak nuclear force were actually different aspects of a single force, the electroweak force.
What is the rolling friction?
The result of deformation of either the rolling object or the surface.
What is a charging by induction?
Results when a conductor is first polarized by a charged object that doesn't touch it. Then one polarity of charge is removed from conductor.
What is a beta decay?
Type of radioactive decay where nucleus emits a beta particle. Electron, from the change of a neutron into a proton. Antineutrino also emitted. Result is nucleus with same atomic mass number but atomic number increased by 1.
How do cell phones work?
Cell phones use the UHF part of the electromagnetic spectrum. 800 to 900 MHz, 1700 to 1800 MHz, and 2100 to 2200 MHz. The service area for a cell phone provider is divided up into hexagonally shaped cells, each one served by base stations with antenna towers at 3 corners of the cell. The stations can both receive and transmit information to cell phones. The stations are connected to a network that uses fiber optic cables. When a cell phone is turned on, it searches for available services according to a list stored in the phone. It selects the correct frequencies to transmit and receive data, then sends its serial and phone numbers to the system, registering itself in that cell. The network makes sure that the phone number is part of its system and that there is money in the account to pay for a call. After registration is complete and a call is made to that phone, the network can direct the call to the correct cell. The cell phone always searches for the strongest signal from a tower. If the phone moves during the conversation, then the signal strengths will change and the phone will hand off the call to a different base station. The technology behind the cell phones we take for granted today is amazing. Transmitting and receiving messages in the electromagnetic spectrum. Cell phones automatically select and correct appropriate frequencies, send serial numbers to servers, and register themselves in the cell in which they are located at the time. Cell phones digitize the voice signals. Special circuits, called digital signal processors, then compress the voice signals and insert codes that can detect errors in transmission. Compression is achieved by sending only the changes in the digital signals, not what stays the same. Cell phone systems also send many different conversations at the same time. One method, called TDMA, time division multiple access, splits up 3 compressed calls and sends them together. CDMA, code division multiple access, uses TDMA to pack 3 calls together, and then puts 6 more calls at 2 other frequencies. Each of the 9, or more, calls is assigned a unique code so that it can be directed to the correct recipient. Spread CDMA systems use a wide band of frequencies that permit more simultaneous calls.
What is an electromotive force, M/?
Potential difference resulting from separation of charges.
What is turbulent?
Flow of fast-moving fluid or object moving fast through a fluid. Causes usually circular or helical motion of fluid.
What is the third law of thermodynamics?
Absolute zero can never be reached.
What factors determine the amount of resistance of a conductor?
The resistance of a wire or other conductor depends upon the following. The length of the conductor, the longer the wire, the more resistance. The cross-sectional area of the conductor, the thinner, the more resistance. The properties of the material, for metals, the fewer the number of free electrons, the more resistance. The temperature of the conductor, for metals, the warmer. The more resistance, for carbon the cooler, the more resistance.
How are microwaves used for communication?
Microwaves are electromagnetic waves with frequencies above about 3 GHz. They are used in homes equipped with wireless internet devices, wireless telephones, Bluetooth devices, for satellite radio and television. In addition, industries, governments, and the military use microwaves for communicating from one installation to another. Microwaves can be transmitted one of two ways. The first is the line-of-sight approach, where the microwave transmitter is pointed at a microwave receiver. These must be no more than 30 kilometers apart. The second method of transmission is to send the signal up to a satellite that receives it and retransmits it back down to a receiving dish.
What is amplitude modulation, AM?
M-wave amplitude changes to represent transmitted information.
What was done to correct the Hubble's vision problems?
Three years after the Hubble was placed in orbit around Earth, a team of astronauts from the Space Shuttle Endeavour installed two tiny mirrors that would correct the focusing problems that the Hubble was experiencing. The telescope has since had several servicing calls, the most recent in 2009. Upgraded detectors and spectrometers have been installed. Faulty positioning gyroscopes replaced, and its batteries replaced. The batteries are used when Earth's shadow blocks the sunlight on the solar panels. Since its repairs, the Hubble Space Telescope has aided research into the age of the universe and the rate at which it is expanding, and has enabled observation of other stars and galaxies that previously were never seen by Earth-bound telescopes. More than 8,000 scientific papers have been published using Hubble data. Equally important, the beautiful photos taken by Hubble have fascinated the public and broadened its understanding of the incredible range of objects in our universe.
What are the two main forms of maglev transportation?
The German system uses the attractive forces between electromagnets to lift The underside of the train 15 centimeters, 6 inches, above its guide rail. The coils in the train and guide rail form a linear motor like an ordinary motor that has been unrolled. The only commercial operation is a train in China that transports people 30 kilometers in slightly over 7 minutes. The Japanese have taken a slightly different approach toward maglev technology. The track and train repel each other. Propulsion also uses a linear motor. Levitation works well at high speeds, but when starting and stopping traditional wheels must be used.
What is a liquid?
State of matter in which the forces keep the atoms close together, but they're free to move. A liquid is a fluid that flows freely and assumes shape of its container.
Where does the bicep muscle attach?
The attachment is close to the elbow, so the forearm is a third-class lever.
What is a generator?
Converts mechanical to electrical energy.
Why are we static when sitting in a chair?
As long as you are sitting in a chair and not moving, relative to Earth, you are static. That means that the chair is supporting you with an upward force that is equal to your weight. You would remain static until some external force was exerted on you to start you in motion.
How is radio astronomy different from radar astronomy?
Radar astronomy measures the reflections of transmitted radio waves to determine an object's size, position, velocity, and surface characteristics. Radio astronomy is like optical astronomy, but it uses the VHF, UHF, and microwave portions of the electromagnetic spectrum rather than the infrared and visible portions. Radio waves penetrate the dust that hides the centers of galaxies and obscures regions where stars are forming. They can also detect hydrogen gas that constitutes 85% of the known mass of the universe.
What is an image, virtual?
Light rays do not converge, but your eye believes that rays came from a single point. Cannot be projected on a screen.
What are the limits of human vision?
Lower and upper boundaries of light. 4x 1014 Hz or 700 nanometers and 7.9x 1014 Hz or 400 nanometers.
What is lepton generation?
Each generation has a charged and unchanged arged particle. In first electron and neutrino, in second muon and muon neutrino, in third tau and tau neutrino.
What is impedance matching?
Impedance is the opposition to wave motion exerted by a medium. When a wave travels from one medium into another, the impedance changes, causing some of the energy of the wave to be reflected back into the original medium. Therefore, not all of the wave's energy travels into the new medium. An impedance matching device between the two media allows for a smooth transition in impedance and reduces reflections.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons, emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
Why are the angles of wings important for supersonic flight?
When a plane breaks the sound barrier, the shock wave in front of the plane has a difficult time moving out of the plane's way. In order to break the sound barrier with less difficulty, aeronautical engineers have designed more aerodynamic fuselages and efficient wing designs. As mentioned above, wings on supersonic planes must remain behind the shock front to prevent structural failure and allow the plane to maneuver safely. The swept-back wing design, as found on both military and commercial airplanes, allows the airplane to accelerate easily and faster before major pressure builds up around the wings. The delta wings, as found on many jet fighters, are large and extremely thin, to keep the wings behind the shock front while increasing lift and reducing drag. Problems can also occur when using swept-back wings. As a plane moves faster, the center of lift on the wings can move too far backward, causing unbalanced forces on the plane, which can affect the maneuverability and safety of the plane.
When was it thought that there were different kinds of electricity?
As you have seen, Benjamin Franklin's kite experiment. showed that lightning and static electricity were the same. Since ancient times humans knew that certain fish, such as the electric eel, could shock a person.
What is a fermion?
Particles like quarks, electrons, and neutrinos with half-integral spins.
What is cosmology?
Study of the formation, properties, and future of the universe, galaxies, and stars.
What is an electromagnet?
Coil of current carrying wire wound on an iron core that produces a magnetic field that depends on the current.
Are there problems with Rutherford's model?
Electrons moving in circular orbits are experiencing centripetal acceleration. All accelerating charges radiate energy. As a result, the electrons in Rutherford's atom would lose all their energy in a tiny fraction of a second.
What is electricity, vitreous?
Produced when glass or precious stones are rubbed.
How do speeds of ocean waves vary?
The speed of an ocean wave depends on the distance between two successive crests, its wavelength. The longer the wavelength, the faster the wave travels. A small surface wave, such as a ripple created by the wind, travels quite slowly because it has such a short wavelength. A swell, the larger, longer wavelength waves created by constant winds, have longer wavelengths and travel at higher velocities. The energy that the wave carries depends on the square of the height of the wave, which explains why high waves can cause so much damage to shorelines. Waves break as they approach a shoreline because the lower part of the wave moves more slowly than the top part of the wave due to increasing friction with the shallower ocean bottom.
What is electrostatics?
Study of the causes of the attractive and repulsive forces, called static electricity, that result when objects made of two different materials are rubbed together.
What is a chromatic aberration?
Defect of a lens that introduces colors into images.
What is a fusion?
Joining of two nuclei to form a more massive nucleus.
How did radio communications develop?
An electromagnetic wave with no changes in amplitude or frequency. Carries no information, it cannot be used for communication. The first method of using these waves to communicate was to switch them on and off in regular patterns. Letters were represented by a combination of long and short pulses using what is called Morse code after Samuel S.B. Morse, who developed the code to transmit information over wires, the telegraph. In 1895, Guglielmo Marconi, 1874 to 1937, a 20-year-old Italian inventor, created a device that transmitted and received electromagnetic waves over a 1 kilometer, 3,280 foot, distance. Later improvements to his antenna and the development of a crude amplifier enabled him to receive a British patent for his wireless telegraph. In 1897, he transmitted signals to ships 29 kilometers, 18 miles from shore, and in 1901 he was able to send wireless messages across the Atlantic Ocean. As a result of Marconi's work on radio transmitters and receivers, he was the co-winner of the 1909 Nobel Prize in Physics. Over the next decade, transmitters and receivers were improved enough that they could be installed in ocean-going ships. Voice communication over the telephone had existed since 1876, but if the distance was to be extended, the voices had to be amplified to be heard. In 1906, Lee De Forest invented a vacuum tube amplifier he called the Audion. It took until 1915 for a radio receiver to be sold using Audions. In 1916, De Forest had developed an Audion-based transmitter that allowed dance music to be transmitted 40 miles. A number of other experimental stations demonstrated music by radio, then called wireless. A large number of radio amateurs made significant advances. When the United States entered World War I in 1917, all stations not owned by the government were shut down, and it became illegal for people to listen to any radio transmission. Samuel S.B. Morse was famous for inventing the Morse code that allowed people to first transmit messages over telegraph wires. During the war, radio was used to communicate between ships and between land and the ships. After the war, amateurs were forced to use only one wavelength, 200 meters, 1500 Hz. Wavelengths shorter than that were thought to be useless for government use. One amateur was able to send signals 3,000 miles. In 1921, transatlantic voice transmissions were made. Companies began to use radio for specialized needs, like to send time information to jewelers to allow them to set their clocks. From 1919 through 1921, radio was mostly used to transmit musical concerts. The first transmission of a football game occurred in November 1919. By 1922, newspapers had developed radio stations transmitting news, weather reports, crop reports, and lectures. Large companies such as General Electric, Westinghouse, AT&T, and RCA began to be involved in developing commercial broadcasting. From 1922 to 1923, as the number of stations grew without regulation, chaos reigned. In 1928, the government announced new assignments in the frequency band 550 to 1600 kHz. Many more assignments were added after World War II, but these regulations are still in use today.
What is fission?
Form of radioactive decay where nucleus splits in two. Extra neutrons and a large amount of energy is released.
What are composite materials?
As was mentioned above, brittle materials like concrete have larger compressive strength than tensile strength. For that reason, reinforcing bars, rebars, made of steel are embedded in concrete. The steel supports the concrete when it is under tension, reducing its tendency to crack and thus keeping it from failing. Composite materials have been used since ancient times when straw was added to clay to make bricks. The most recent composite materials use carbon fibers, less than 0.01 mm in diameter, that are light in weight. They're made of pure carbon, with very high tensile strength but low compressive strength. They are added to plastics to make them more rigid, increase their Young's modulus, without adding weight. Golf club shafts are often made of a plastic filled with carbon fibers, giving the shaft great strength with low weight. By varying the amount of carbon fibers, the flexibility of the shaft can be changed. Although it isn't really a composite, glass can be made to be less brittle. The key idea is to keep the surface under compression at all times so it won't crack. Glass sheets are made from the fluid state by cooling. If the surfaces are cooled quickly with strong blasts of air, it produces a form of glass called case hardened that was used for shatterproof lenses in eyeglasses. In the 1970s, a chemical method was invented that could be used on cold glass. It involves putting the glass into a bath of potassium salts. The potassium replaces sodium in the surface layers of the glass. The larger potassium atoms expand the surface layers so that the interior portion of the glass compresses the surface, keeping it from developing cracks.
What is sound intensity?
Sound intensity is the power in the sound wave divided by the area it covers. Power is energy per unit time. So the intensity is the wave energy passing through a surface point divided by the time taken. The energy transferred by the wave is proportional to the square of the amplitude of the wave. In the case of sound, the amplitude is the amount the peak pressure in compression is greater than the average pressure.
What is the ITER project?
International effort to produce electricity from nuclear fusion.
What is a sonic boom?
Caused by a shock wave produced when an aircraft reaches the speed of sound.
What is a solar eclipse?
An eclipse of the sun occurs when the moon casts its shadow on Earth. As the moon moves between Earth and the sun, darkness falls upon the small part of Earth where the moon blocks the light.
Why are dams thicker at the bottom than at the top?
Dams hold back bodies of water, and water pressure increases with the depth of the body of water. So the pressure from the water pushing horizontally on the dam is greater at the bottom than at the top. If holes were bored near the bottom, middle, and top of a dam, the longest horizontal stream of water would fire out through the bottom hole because the water pressure is greatest there.
What is nuclear physics?
Study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed.
What is an induced drag?
A consequence of the lift generated by the wing. Induced drag causes vortices.
What is quantum mechanics?
Study of atoms by themselves, as well as in molecules, liquids, and solids in which the wave nature is important.
What is a refractor telescope?
Uses one lens to gather, refract, and focus light toward an eyepiece that contains one or more lenses that create an image that the eye can see.
What is a light detector?
converts light energy to another form of energy.
How can these two forces that are so different in strength and range be unified?
It only happens at extremely high energies, corresponding to a temperature of 1015 K. Such as occurred in the first few moments after the Big Bang or in an accelerator. They received the 1979 Nobel Prize for their work.
What are the Van Allen belts?
Charged electrons and protons from solar wind and cosmic rays entering Earth's magnetic field. Feel the Lorentz force that traps them into spiral orbits about the magnetic field lines. They create donut-shaped regions of charged particles called the Van Allen belts. The belts are concentrated around the equator and become thinner as they approach the poles. The two belts are located at 3,200 kilometers and 16,000 kilometers above the surface of Earth.
What is the luminous power?
I response to power of light electromagnetic waves.
How much energy is contained in a lightning flash?
An average lightning bolt transfers about 5 coulombs of charge and about 500 million joules of energy. The transfer takes about 30 millionth of a second and the electrical power in a bolt can be as large as 1000 billion watts.
Is energy conserved?
While total energy is conserved, the kinetic energy before the collision is much greater than the energy afterward. Much of the energy goes into bending metal and breaking glass and plastic. Automobile crash reconstruction is a way of using conservation of momentum to figure out the speeds of one or both of the cars before the collision. Kinetic energy is not always converted to other forms of energy in collisions. The toy Newton's cradle has a set of steel balls that swing on strings. In these collisions, kinetic energy is almost totally conserved. The incoming ball stops when it hits a second ball, and the second ball moves away with the same speed. And thus kinetic energy, as the incoming ball had. Collisions of pool or billiard balls is another case where kinetic energy is conserved. This kind of collision is called elastic, while the case of cars colliding is called inelastic. A hot object has thermal energy. How can it transfer this energy? What happened to the increased thermal energy of the eraser and your hand, or to the block and the table? A short time later all will have cooled. They have transferred their thermal energy to the cooler surroundings. Energy transfer that results from a difference in temperature is called heat. Heat always flows from the hotter, energy sources, to the cooler objects, energy receivers. Thermal energy can be transferred in three ways: conduction, convection, and radiation. Conduction occurs when two objects are in contact, like when you put your hand in hot water. Convection is the motion of a fluid, usually air or water. The fluid is heated by the hotter object, then moves until it contacts a colder object where it heats that object. You can think of convection as two instances of conduction. Radiation is infrared waves that are emitted by hotter objects and absorbed by colder ones. You can feel radiation if you bring your hands near a hot electric burner on a stove. The sun heats Earth by radiation.
How do metal detectors work?
Built into the frame of a metal detector are coils of wire that carry a current. When metal is close to the coils, the magnetic properties of the metal change the current in the coils of wire that is detected by the electronic circuits in the detector. When you walk through a metal detector with metal anywhere on your person, that metal changes the current in the coils in the frame of the detector.
What causes the flow of charges in a voltaic pile?
Volta invented the term electromotive force, EMF, to describe what causes the separation of charges. The more disks there were in the voltaic pile, the greater the EMF. Unfortunately, the word force is an incorrect use of that term. Because there is no mechanical push, measured in newtons, on the charge. The correct term is potential difference or voltage, the energy change per unit charge separated. Both the term voltage and the unit in which it is measured, the volt, V, are named after Volta.
Who would become the most influential scientist of the 20th century?
On March 14, 1879, Albert Einstein was born in Ulm, Germany. No one knew that this little boy would one day grow up and change the way people viewed the laws of the universe. Albert was a top student in elementary school where he built models and toys and studied Euclid's geometry and Kant's philosophy. In high school, however, he hated the regimented style and rote learning. At age 16 he left school to be with his parents in Italy. He took, but failed, the entrance exam for the Polytechnic University in Zurich. After a year of study in Arras, Switzerland, he was admitted to the university. 4 years later, 1900, he was graduated. He spent 2 years searching for a job and finally became a patent clerk in Bern, Switzerland. During the next 3 years while working at the patent office he developed his ideas about electromagnetism, time and motion, and statistical physics. In 1905, his so-called Annus Mirabilis or miracle year, he published 4 extraordinary papers. One was on the photoelectric effect, in which Einstein introduced light quanta, later called photons. The second was about Brownian motion, which helped support the idea that all matter is composed of atoms. The third was on special relativity, which revolutionized the way physicists understand both motion at very high speeds and electromagnetism. The fourth developed the famous equation E equals mc2. While these papers completed his PhD requirements, it was 2 years before he was appointed a professor at the German University in Prague.
What are the Van Allen belts?
Charged electrons and protons from solar wind and cosmic rays entering Earth's magnetic field. Feel the Lorentz force that traps them into spiral orbits about the magnetic field lines. They create donut-shaped regions of charged particles called the Van Allen belts. The belts are concentrated around the equator and become thinner as they approach the poles. The two belts are located at 3,200 kilometers and 16,000 kilometers above the surface of Earth.
What is an electron volt, EV?
Energy particle with charge of an electron or proton obtains by being accelerated by 1 volt potential difference.
How does the gravitational force cause the motion of planets?
In antiquity, the planets, the name comes from the fact that they seem to wander across the sky, were assumed to have circular orbits. In order to account for the observations, their motion was thought to involve circles attached to other circles. In between 1600 and 1605, Johannes Kepler, 1571 to 1630, made careful studies of the observations of Mars made by Tycho Brahe, 1546 to 1601. He found that a circular path required Tycho's observations to be wrong by 2 minutes of arcade. 4 times the apparent size of the Moon, but he knew that Tycho's work was better than that. After some 40 failed attempts, he finally discovered that the orbit could be described as an ellipse. We now know an ellipse fits the orbits of all planets, comets, and other bodies about the Sun, as well as satellites about planets. The shape of the orbit is called Kepler's first law. An ellipse is not a circle. So the gravitational force of the Sun is not always perpendicular to the motion. Therefore the planet's speed changes as it moves around its orbit. Kepler's second law says that in equal times planets sweep out equal areas. Thus if the planet is closer to the Sun, it will move faster than it does when it is farther away. Kepler's third law was actually obtained in 1595 and was based primarily on philosophical and theological arguments. It stated that the relative sizes of the orbits of planets around the Sun could be obtained by nesting the 5 Platonic solids: the cube, tetrahedron, dodecahedron, icosahedron, and octahedron. The planets' orbits were in the spheres that circumscribed each solid. Today we state this law as the square of the period of the planet is proportional to the cube of the radius of the orbit. The proportionality constant depends on the mass of the object about which the orbit occurs and the universal gravitational constant. The law summarizes two of the properties of orbits of planets or satellites about a central star or planet.
What is the first law of thermodynamics?
The first law of thermodynamics is a restatement of the conservation of energy. It says that the energy loss must equal the energy gain of a system. It relates the heat input and output, the work done on the system and the work the system does, and the change in internal energy, or temperature change. For example, the cylinder and moving piston of an automobile engine is heated by the burning of gasoline in the cylinder. The piston moves out, doing work, and heat is transferred to the coolant because of the higher temperature of the cylinder and piston. As long as the temperature of the cylinder and piston does not change, the heat input equals the work output plus the heat output. Energy isn't gained or lost, it just changes form. Another way to state the first law is that net heat input equals net work plus change in thermal energy. Note that heat can be either positive, heat input, or negative, heat output. Work can also be positive, work done by the system, or negative, work done on the system. Thermal energy can also go up or down.
What is a beta decay?
Type of radioactive decay where nucleus emits a beta particle. Electron, from the change of a neutron into a proton. Antineutrino also emitted. Result is nucleus with same atomic mass number but atomic number increased by 1.
What is thermal energy?
The sum of the kinetic and elastic energy of the atoms and molecules.
What is chemical physics?
Study of the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions.
What will happen to the ever-expanding universe?
If the acceleration of the universe continues in many billion years, galaxies beyond the Milky Way and its companions will become invisible because their apparent velocity as seen from Earth would exceed the speed of light. In some models, dark energy would rip apart all galaxies and solar systems, and eventually become so strong that it could tear apart atoms and even nuclei. The universe would end in what has been called the Big Rip. In other models, gravity would again take over, causing the universe to contract and end in the Big Crunch. More measurements of acceleration are needed to decide between these two ultimate ends.
What does sustainable energy mean?
The amount of fossil fuels is limited. There have been major advances in discovering oil and extracting more from existing reservoirs, as well as recent advances in obtaining natural gas and oil from shale. But these sources, as well as coal and uranium, are not being replaced. Sustainable energy sources, primarily wind, water, and solar energy, ultimately receive their energy from the sun, and therefore will be available for billions of years. The present use of these sources is minimal. There are many difficulties in increasing their use. Wind power is highly variable. Water energy from traditional dams and reservoirs causes environmental problems. Energy from waves and tides has yet to be developed widely. Solar energy can be directly converted to electricity using photovoltaic cells. But these cells, at least at present, are inefficient and costly. Large solar farms exist, at which solar energy heats a fluid so it can boil water to use with steam turbines driving electrical generators. An additional problem in increasing the use of many of these sources is that they require the use of very rare materials, which are both costly and not easily obtained. Nevertheless, recent analyses suggest that a combination of nuclear, wind, water, and solar energy could replace most of the use of coal and oil for electric energy production.
Where does the bicep muscle attach?
The attachment is close to the elbow, so the forearm is a third-class lever.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
How do you use specific heat capacity information?
Specific heat capacity is the energy per kilogram per change in temperature. So, to find the amount of energy needed to heat something, you need to know the material, its mass, and the change in temperature desired. For example, if you wanted to increase the temperature of 2 liters, 2 kilograms of water from room temperature, 20 degrees Celsius, to the boiling point, 100 degrees Celsius, you need to multiply the specific heat capacity of water, 4186 J/kg degree C, by 2 kilograms and by 80 degrees Celsius to obtain 669,760 J, or about 670 kJ. Suppose that the water is placed in an aluminium pan with a mass of 300 G, 0.3 kilograms.
What happens if more than one force acts on an object?
You can explore this question with your toy car or ball. Try exerting 2 forces, like 2 finger taps in the same direction. You can see that the car or ball moves faster. The forces add.
What type of wave is a sound wave?
A wave that consists of compressions and rarefactions such as a sound wave is called a longitudinal wave. The medium. The material through which the wave is traveling, does not get transferred from sender to receiver. The molecules only vibrate back and forth about a fixed position. The wave does, however, carry energy from its source to the receiver.
What is angular velocity, CO?
Equivalent of velocity for rotational motion.